Today we'll be talking about something many of you probably do every day at work, measurements. But I'm going to ask you to look at the kinds of measurements we'll be talking about today, primarily headphone measurements, from a consumer standpoint, from the perspective of someone who does not have all of your physics or engineering education, training, or time in the lab. In this talk, we're going to be looking at audio measurements as consumer content, and that's the title of this talk, just to make sure you're in the right session. Audio measurements as consumer content. What was once behind the scenes is influencing audio enthusiasts today. While this may end up being one of the less technical of the sessions at this conference, I think you'll find it interesting anyway, because again, in this session, we'll be talking about something some of you probably do regularly at work. Audio measurements, something that we audio enthusiasts have become fascinated by over the years, so much so that many enthusiasts will perform their own audio measurements, some doing them quite well, others perhaps not as much. And even more enthusiasts will then try to interpret those measurements, and many of those enthusiasts seem, in my estimation, to be just as likely to misunderstand the measurements they're looking at as they are to understand them. And through it all, for better or worse, many audio enthusiasts today are heavily influenced by audio measurements. My name is Jude Mansilla, and I'm the founder of a website called Headphone.org. We started Headphone over 20 years ago, and it's grown into one of the most popular websites focused on audio gear, with our focus more specifically being headphone audio. On Headphone, we have a very active community of audio enthusiasts who discuss, review, and even measure headphones and other audio gear, which is what this talk's about. When not in the midst of a pandemic, as a community, we also regularly get together in person with privately organized meets and gatherings all over the world. Additionally, Headphone produces a headphone expo and trade show called CanJam, with 7 events internationally, including 3 in the US, 2 in China, and London and Singapore. And at Headphone's office here in Michigan, we have an audio measurement lab with, among other things, a state-of-the-art audio analyzer and the latest hearing simulators. I'll show you more of what we're using and how we use it later. And just about every day we're on chat, Zoom, or on the telephone with industry engineers and product team members discussing audio measurements, mostly headphone measurements. So, getting back on topic, again, audio enthusiasts are being increasingly influenced by and absolutely obsessed with audio measurements. And you might be wondering at this point what the significance of all this is. Well, in a 2017 study by the Enthusiast Network, who used to publish Interfidelity, Stereophile, Motor Trend, Automobile Magazine, and many others, in their study of enthusiasts, they found that people are 3 times more likely to come to an enthusiast for advice before making any purchase. Home tech enthusiasts are approached for home technical advice by friends and family 3.4 times the national average, and for advice on new technology in general 2.4 times more than non-enthusiasts. For those of you out there who are the audio guys in your circles, you're probably not surprised by any of this. I can't tell you how often I'm asked about which headphones or other audio equipment to buy in a given price range or form factor by acquaintances, friends, family members, and I suspect that's probably true for many of you too. And it's not just you and me. Audio enthusiasts all over the world are no doubt influencing the purchasing decisions of many others, many thousands of others, in addition to spending a lot of money themselves. Because enthusiasts are twice as likely to pay more for high-quality items, have an average net worth 50% higher than the national average, and are twice as likely to be early tech adopters. So going back to what I was saying earlier, audio enthusiasts are increasingly being influenced by audio measurements. Anyone paying attention to the online world of audio reviews and online discussion knows this. And yes, I'm an audio enthusiast, and I have been since I was a kid. If you've been around as long as me, then you remember the popularity of stereo rack systems, tuner, preamp, amp, cassette deck, turntable, all in one rack, and typically packaged with some large loudspeakers that were as tall as the rack to aesthetically match to form a visual monolith of mediocre sound. Back then, you could get rack stereo systems at department stores, appliance stores, hilariously, anywhere but dedicated audio stores. Well, at some point, we had just such a rack system in our house by Fisher when I was growing up. And it was with this system that I had my first exposure to audio measurements. You see, on the front of our rack system loudspeakers was something that looked like this. Now, we here know that's a frequency response plot, but at the time, as a kid, I had no idea what that was. To a kid, it looked very impressive, though, very official. Graphs look authoritative, and that bears repeating. Graphs look authoritative and scientific. I didn't know what it meant at the time, but I figured it must have had something to do with why that stereo system could play loud, shake our house, and impress my boyhood friends. When I was putting this presentation together, searching the web for a photo of this, I also found this. And this. And this. and so on. Notice that from photo to photo, the model numbers are changing. Every one of these shows a different Fisher loudspeaker model number. But I think by now you're noticing that something funny is going on. Either Fisher's engineers and manufacturing were astonishingly consistent, able to hit the exact same frequency response target from model to model over a period of many years, or they were just putting us on with a bit of on-product marketing. I think we know the answer, but again, graphs look authoritative. And that's largely been the story of consumer-facing audio measurements from manufacturers, especially with mass-market audio products, where consumers are met with specifications and occasionally graphs that either originate or are optimized by any number of people outside of the engineers at those companies. Now, more die-hard audio enthusiasts might be unmoved by these specs, unconvinced by a lot of the manufacturer-provided specifications, but it doesn't mean they don't care about what the specifications actually are. On the contrary, audio enthusiasts are increasingly obsessed with audio measurements, and they'll look for measurements whenever and wherever they can. For decades, there have been professionally published audio magazines, and now websites and blogs and chat rooms too, making and sharing audio measurements. Sometime in my teens, after I realized there was better sounding gear out there, gear beyond the rack systems we had, I started reading audio magazines. I think I was 13 years old when my parents got me a subscription to a magazine called Stereo Review. Yes, when most of my friends were reading Car and Driver and Motor Trend to lust after cars they couldn't drive or afford, I was reading Stereo Review to lust after audio gear I could not afford. Stereo Review was a magazine that published reviews of audio gear, and very relevant to this discussion, they also published audio measurements by the late Julian Hirsch of Hirsch-Hauck Labs. Of course, at first blush, I had no idea what any of those measurements meant. Over a period of years, though, I started to figure out the basics and then some, and then over more time started looking forward to seeing the measurements, sometimes as much as I wanted to read the reviews. Even then, by the way, the discussion of audio measurements and correlation with subjective opinions, perhaps not surprisingly, it could be controversial even then. Stereo Review was not the only magazine to offer audio measurements. Paul Miller and Keith Howard have been publishing audio measurements in Hi-Fi News. Of course, in the last couple of decades, perhaps the best-known consumer-facing audio measurements have been those published in Stereophile, with editor John Atkinson usually doing the measurements separate from the subjective reviews by the other writers. I always found this an interesting and fun way to go about it, as subjective impressions and measured results in Stereophile don't always match up. Whether the measured performance and subjective reviews match up or not, it's always interesting in Stereophile to kind of line them up to see both the matches and the discrepancies. I'm a great admirer of John Atkinson's work at Stereophile. But specifically in the world of headphones, which is the part of the audio world I primarily reside in, there was a rather singular figure who brought headphone measurements to consumers before anyone else I can remember. He's retired now, but a man named Tyle Hertzens, as intelligent as he was zany and eccentric, was the first I can recall to show consumers the type of headphone measurements that up to that point were only seen in research and product development labs behind the scenes. He started doing it first from his online high-end headphone audio retail store in Montana called Headroom, and then later and most popularly with the website Interfidelity, where Tyle served as its editor until his retirement. Through his consumer-facing headphone measurements and accompanying articles with Headroom and then Interfidelity, Tyle Hertzens was the first person I can remember to explain to laypeople like me how, for our purposes, headphones must be measured on an ear simulator, and why those headphone measurements in their raw form, even when ideal, essentially never appear flat. Tyle was the first person I can recall explaining to our community of headphone enthusiasts the transformation of the sound field that occurs as it makes its way to our eardrum. He was inimitable, and our community still misses him deeply since his retirement over 3 years ago. Interfidelity under Tyle was prolific, releasing articles and headphone measurements very regularly. But as often as Tyle and his team released that content, and again, it was quite often, quite regularly, it simply was not fast enough to meet the faster growing demand for the very thing Tyle had started us on, headphone measurements. And that's when many members of the community decided to start measuring headphones themselves. Most of the enthusiasts who initially took up measuring headphones did not understand that to properly measure a headphone for our purposes, you could not measure a headphone the way you would measure a loudspeaker. I think most simply and erroneously thought the mannequin's purpose, like the head acoustics head that Interfidelity was using, was just to provide a human-like shape to mount the headphone on and some type of coupling simply to position the headphone over a microphone. It was quite clear, as I'll discuss shortly, that they did not understand that there was also a hearing simulator mounted within the measurement mannequin to mimic the ear canal volume and eardrum and to mimic the complex air load therein that affects the way the driver in the headphone or earphone behaves. And if they didn't know about or understand those things, then they wouldn't have known that we need to simulate those things. Simulate the transformation of the sound field that occurs as it makes its way to our eardrum. And especially when we couple head-worn devices like headphones and earphones to this hearing system of ours. So as I'll show you shortly, the measurement fixtures they built, these DIY, these do-it-yourself measurement fixtures, did not take any of that into account. They were built simply to provide something to clamp a headphone over a microphone with. That's it. Now, if the enthusiasts building and using the DIY measurement fixtures don't know about proper hearing simulation and its effects, then it shouldn't be surprising that most enthusiasts hungry for headphone measurements do not either. As is often still the case today, the appetite for headphone measurements could be so ravenous that perhaps not enough questions were asked about where they came from, how they were done, what was used to do them. They just wanted headphone measurements and more of them, as many of them as they could. Regardless of how it was done, if it had an x-axis, y-axis, and a squiggly line that was generated somehow from the output of a headphone, it was given the benefit of the doubt. It was viewed as bona fide. And this is why I asked of you at the very beginning of this session to try to consider what we're discussing here from a consumer standpoint, from the perspective of someone who does not have all your physics or engineering education, training, or time in the lab. Without the experience of measuring headphones, or not having done any other types of acoustical measurements, the headphone measurements, regardless of where they're from, can be taken too readily at face value by audio enthusiasts, by the consumers. And I'm not saying this with any intent to disparage or make fun of consumers for doing this. I also do this myself. I think many of us do. When it comes to cars, for example, which I have no expertise in beyond any typical consumer, if you tell me that a model has 300 horsepower and 200 pound-feet of torque, and especially if you show me graphs of such, I'm probably going to accept that information at face value. Most probably would. If you tell me you tested a video monitor and found it covers 98% of the sRGB color gamut, I'd be inclined to think you knew what you were doing, and I would likely accept that information, that data, at face value. Being completely honest, I know even less about video monitors and color gamut than I do about cars. Anyway, not surprisingly, we see this very commonly with headphone measurements also. That is, taking at face value whatever headphone measurements are posted. And this brings me to an example of what can happen when this happens. When it comes to headphone measurements, here's just one example of enthusiast-generated headphone measurements that perhaps deserve to be examined a bit more closely. It was a frequency response measurement of one of Sony's flagship over-ear headphones, the Sony MDR Z1R. This measurement somewhat loosely resembled a measurement of that same headphone by Tile Hertzens at Interfidelity. Here's the enthusiast's measurement. Now let's look at Interfidelity's measurement of that same headphone model. Just a note about Interfidelity's measurements here. The plot on the top is compensated. Because Tile Hertzens measured on the Head Acoustics HMS2 measurement mannequin, he would show his frequency response measurements two ways. The bottom plots were his raw or uncompensated measurement seedings. In any given set of measurements, though, it was the plots on top that Tile most emphasized, and so then did his readers. The top plots represented the average compensated response from those raw seedings, compensated using the independent of direction compensation by Head Acoustics, which Tile said was quite similar to the diffuse field response. Now, because that enthusiast measurement that I showed you just before Tile's, and actually let's take a look at them side by side right now, because it looked similarish to Tile's compensated measurement of the same model of headphone, that enthusiast measurement was accepted by many other enthusiasts as a worthwhile measurement of this headphone. And so then, other headphones this DIYer might also measure. And if this DIYer's graph output was somewhat the same in appearance as the graphs from someone we knew to be experienced in using industry standard type measurement gear, like Tile Hertzens, perhaps this DIYer's methodologies and setup paralleled Interfidelity's measurement lab, right? Well, in commenting about that headphone's measurement that he posted, about what he used to measure that headphone with, this particular enthusiast and DIYer said this: I made the last measurement. That spike is much bigger than others. I would not necessarily trust mine completely. My measurement rig is a piece of leather and some felt tapped to a broken lamp, but it does seem relatively accurate for most measurements. Well, at least he was forthcoming about his setup. But gosh, I was extremely curious to find out how one would use a piece of leather and some felt tapped to a broken lamp to measure an over-ear headphone. I searched and found a photo of that measurement fixture. Now, looking at that, in case you're unclear about how the headphone is mounted to that fixture, and I definitely did not understand that just from his word description, I think the following photo here, which may be kind of a version 2 of that previous measurement fixture, shows how the headphone sits on them. By the time I saw this, actually it was well before I saw this measurement and the description and then the photos of this gentleman's measurement fixtures, by the time I saw all that, I was already aware of the fact that a lot of the DIY measurement setups, or measurement rigs as we call them in the community, were having an outsized impact on the perception of the performance of headphones measured on them. For quite some time, it was these DIY measurement rigs, because there were so many of them in use, that were defining the perceived measured performance of so many headphones. Thousands of enthusiasts, hundreds of thousands of enthusiasts, maybe more. Headfi.org alone reaches over 1 million unique visitors per month. So many headphone buying enthusiasts were looking for and judging headphones based on the measurements coming from these DIY measurement setups. A search through the communities shows just some of the measurement setups that for years were generating the bulk of online headphone measurements. Let's take a look at some of them. Here we're looking at the leather felt broken lamp fixture still again, as well as its successor. And I'm going to explain that piece of felt shortly, as you'll see it pop up in several of the next DIY measurement rig photos. These were, and perhaps still are, commonly in use. Cardboard boxes with microphones pushed through them. I think Dayton mics were popular with these kinds of setups. Because the microphones were so long, you can see how in the photo on the left the headphone is being stretched to a fairly unnatural degree. Of course, this would make for an unrealistic caliper pressure and angle of pressure. You see the opposite side earpiece is pushed up. If you could see underneath the measured ear cup, there'd be a felt piece. Again, I'll explain that shortly. On the box measurement fixture on the right, you can see a felt surface again, and the microphone pushing through that. The fact that this is a headphone box was certainly more theme consistent, but probably no more accurate. In this one, there's that felt piece again. This one looks like some kind of paper towel roll with a microphone going through the middle of it. Again, because the microphone being used here is so long, you can see the Sennheiser HD650 headphone is being stretched, perhaps even abused, to a rather extraordinary degree in order to measure it. The paint on the headband actually looks like it's chipping, perhaps from this kind of strain applied to that headband routinely when measured. Here are a couple more box-type fixtures on the right and in the middle. You can see the felt on those too. The one on the left uses foam blocks to form the fixture body. I thought that one was one of the more elegant ones. This one has a bit more structure with what looks like maybe PVC pieces, but again, the long microphone results in that exceptional stretching of the headband. Again, the caliper pressure is probably a bit severe here and not realistic. Not that that's the only problem with respect to realism here. Another box measurement rig. This one has the foam piece in the middle instead of felt. The one on the right, again, stretching that headphone out rather substantially. You can see the earpiece is oriented in a way that isn't likely to be how it would sit on a human head. Now, this folded foam measurement rig was actually for years the measurement fixture that generated some of the most popular, most talked about measurements in the community. A huge number of publicly posted headphone measurements were made on this fixture, long before anyone had seen this fixture or known anything about it. And this is version 2 of that foam setup that I just showed you in the previous photo. I believe it's this fixture, which perhaps is intended to look a little bit like a Gros 45CA. I think it's this fixture that popularized the use of those foam and felt pieces you saw in so many of the previous DIY setups. The designer of this fixture described the use of those pieces as follows. In the middle of the foam layer, a piece of felt about the size of an ear. Without this piece, I found measurements too ringy. Covered completely with felt, I found measurements too damped. The felt the size of an ear also serves another function, proper measurement of supraorals that rest on the ear. As you know, supraoral headphones are on the ear headphones as opposed to around the ear headphones. But would a piece of felt or foam this size appropriately serve as a pinna for properly measuring supraorals or anything else that would engage a pinna for that matter? I don't think so. But again, these and many more measurement setups like them generated the bulk of the headphone measurements we saw online for several years, and that's why so many of them have that foam or felt piece. Now, if you're wondering how the leather felt broken lamp measurement fixture generated a measurement that looked somewhat similar to interfidelities, I believe it's because most of the DIY measurers were of the belief that they could approximate the results from industry standard fixtures, fixtures like Interfidelity's Head Acoustics Mannequin, also fixtures from Brüel and Karen Gross. They felt they could approximate the responses from those with their DIY setups by measuring a couple or a few headphones, comparing those measurements to measurements of the same headphone models on the standardized fixtures, and then from that come up with an average compensation that they'd apply to the raw results from their DIY fixtures. Anyone watching this already understands the problem with doing this. However, I think most of the DIY headphone measurers did not understand the complexity of the interaction between the headphone and humans, or for our purposes, hearing simulators that simulate humans, but this is what they did.
Long story short, I think this DIYer's measurement of that headphone looked somewhat like Interfidelity's measurement of it because it was sculpted to look that way after the fact through post-measurement compensation. Searching through conversations in the DIY measurement communities, you'll find many discussions about coming up with compensation curves and values to work with many different types of DIY measurement fixtures. These kinds of compensations were being changed, applied, reapplied to measurements from these kinds of fixtures frequently and routinely. Really, it was during those times that we started thinking seriously about doing headphone measurements at Headphone. I learned from reading Tile's content, as well as from my relationships and regular communications and visits with many different headphone engineers, and having visited several of the facilities where many of the headphones our community loves were researched and developed. Also from reading and researching what feels like countless thousands of pages on my own. I learned enough through all of that to understand at least the fundamentals of headphone measurement. Enough to know that the DIY measurement fixtures were falling short and at best misleading. Of course, the intent of those using the box measurement fixtures and the paper towel roll measurement fixtures and the leather and the felt and the lamp, the intent was good. But again, the results were no doubt misleading, inaccurate. Anyway, seeing how those measurements from DIY setups were being used again, I thought that we might want to start measuring headphones at Headphone, informed by everything I just mentioned. Maybe do it a bit more formally, add another voice to the mix. The final push came in 2014 when Paul Barton of PSB, whom I consider one of my mentors, paid us a visit. PSB is a popular maker of loudspeakers, and Paul Barton came from the same working group as gentlemen like Edgar Shaw, Floyd Toole, Sean Olive from Canada's National Research Council, or NRC. Anyway, Paul came to visit us at Headphone in 2014 and brought a small Gross measurement fixture with him, a Gross 43AG, and was showing me how to do headphone measurements straight away. For any of you who know Paul, you know he's a natural teacher, very professorial. We've also had the privilege of visiting Paul Barton at the NRC in Canada, where he showed us how he measures headphones and loudspeakers there. Paul Barton's push for us to measure and to have ongoing discussions with him and other headphone industry people, his visit and that push made us pull the trigger. I think it was the next day we were in touch with Gross to order our own fixture for our office at Headphone. We went with the Gross 45CA, and since then we've measured with the Gross 45CA, which we still use as our IEC 711 fixture, and we've also measured with the Gross Keymar, and now we're measuring with the new Brulin Care Hats Type 5128, an entirely new standard. I'll get back to the 5128 momentarily. In fact, I'll give you a quick tour of our little lab at Headphone shortly. We were not alone in following Interfidelity to try to do more proper headphone measurements. Ratingscom is a popular website for measuring many different types of audio and video gear, including headphones. Hobbyists started picking up ear simulator clones that are marketed as being IEC 711 compliant, but might be more accurately described as 711-ish, as it's been demonstrated online that they're not nearly as consistent and don't tend to exactly match 711 transfer impedance and tolerances to the degree and consistency that 711 simulators from Brulin Care and Gross do. But for the sake of hobbyist measuring, the results are still going to be closer to industry standard fixtures with 711-ish clones from Taobao than a piece of leather and some felt tapped to a broken lamp. Now there are several more review sites, bloggers, YouTubers, and a whole lot of independent hobbyists picking up those 711 clones, and some of them have even started upgrading to bona fide 711 fixtures from Gross and Brulin Care.
Even with the increasing adoption by measurement enthusiasts of more standardized ear simulators that are compliant with the IEC 6318-4 standard, which I've been referring to by its old name 711 throughout this presentation, even with the move to 711 configurations that are compliant with international standards, the community is still faced with measurement uncertainties in the consumer-facing headphone measurements world, and there are probably many reasons for this. Among them is the variety of standardized configurations, inside of which are 711 ear simulators. A 711 equipped configuration might look like this. Or this. This is also a 711 equipped fixture. So is this. And this. And some measure with just the 711 simulator and a simple metal canal extension like this. And there are still more such configurations. In my presentation at last year's HBK Product Physics Conference, I briefly covered how measuring the same in-ear headphone model on 4 different 711 equipped fixtures can result in substantially different frequency response measurements. This is the Westone W60 in-ear headphone measured on 4 different 711 equipped configurations. These were measured by experienced headphone measurers that I found online and put them together for comparison. In this graphic, they're normalized at 1 kilohertz. In this one, they're normalized at 500 Hz. Again, these are all independent measurements of the same model of earphone, the Westone W60, on 4 different configurations using 711 ear simulators. Looking at the original 1981 IEC 6711 standard, the 711 simulator is intended to present an appropriate input impedance or transfer impedance at a reference measurement plane where the device to be tested is placed. There's a reference plane. As time progressed and as 711 represented the best available such simulator, all varieties of extensions, attachments, adapters, and fixtures were developed to allow the coupling of different product form factors to the 711 simulator for testing. There's a report from ISVR Consulting that was published in 2003 titled Background Information on Head and Torso Simulators and Relevant Standards that was undertaken to compare the various national and international standards and other documents relative to head and torso simulators, to examine how the standards relate to each other, and how the HATS, head and torso simulators from various manufacturers, conform to the standards. Among the findings, in this specialized field, the standards appear to have been led by the hardware, not vice versa. It would possibly be more accurate to say that a particular standard conforms to a particular HATS, not that the HATS conforms to the standard. Slight deviations from and minor adjustments to the standards and revisions between different versions of the same standard suggest that manufacturers continue to lead with the standards left to follow. There are differences in head and torso dimensions among the KEMAR, B&K, and Head Acoustics HATS. And the writers of the report asked, how important are these differences? Should standards have tolerances wide enough to encompass all the different HATS? Will wide tolerances lead to difficulties if different laboratories use different HATS? What precision and repeatability is necessary in measurements made using a HATS? So again, in order to accommodate the coupling of different product form factors to 711 simulators for testing, resulted in the addition of all kinds of extensions, adapters, attachments, and fixtures, many of these becoming standardized to make them official. And since that report, there are now even variations of the 711 simulators themselves that can result in substantial measured differences, even in otherwise identical configurations. Well, if the questions were being raised, investigations being done by measurement industry experts at what was then the United Kingdom's Department of Trade and Industry through their National Measurement System Program for Acoustical Metrology, undertaken by the National Physical Laboratory, NPL, and the Institute of Sound and Vibration Research, or ISVR, just to try and sort these out, the standards, the differences. Where does that leave consumers, lay people like me, who haven't been so trained and who, without self-education, don't know all of this or any of this? I wish I had a simple answer, but I don't. Anyway, because of this, enthusiasts commonly compare the measurements from these various 711 configurations to each other. They also compare measurements from various configurations to targets like the popular and well-researched Harman target, even though many of these enthusiast measurements they're comparing were made on measurement fixtures and configurations quite different from the types the team at Harman used for their target research. Now, earlier I mentioned how enthusiasts tend to take measurements at face value, and here's a simple example of this we were recently discussing on our forums. If I posted this seating showing the frequency response measurement of both channels of a pair of headphones, this is the Dan Clark Audio Stealth, by the way, it would no doubt be concluded by many, probably most enthusiasts, that this headphone has some left-right channel imbalance. But here's another couple of seatings of that exact same pair of headphones. Unless otherwise noted, we typically post averaged frequency response measurements from several seatings. But some reviewers who post measurements post results from single seatings only. Again, audio enthusiasts tend to take measurements at face value. X-axis, Y-axis, squiggly lines, bona fide. So if I was going to select only one of these 3 seatings of the Dan Clark Audio Stealth to show you, which one I choose could have a substantial impact on the perception of this headphone's measured performance. We also see issues pop up when it comes to comparing the frequency responses of at least 2 pairs of headphones, something that for obvious reasons is done very often. Typical practice when measuring headphones is to adjust the voltage to the device under test until it outputs a certain frequency at a certain level, 500 Hz at 1 Pascal, 1 kHz at 90 dB SPL, etc. What we end up with from any one measurer then is a bunch of frequency response measurements that always cross at a given frequency. But is that an acceptable basis for a comparison that would reliably correlate with our subjective experience comparing the tonal balance of 2 or more headphones? We're going to revisit this in a couple of minutes because I'm going to be asking for your help on this. Also possibly adding to the confusion among enthusiasts and even some pros was the release of Brüel & Kjær's new HATS Type 5128. It was the first all-new standard in hearing simulation in 40 years, but in my opinion, it was sorely needed. Unlike 711, the 5128 simulates average adult human hearing across the full audio range for the first time ever. Most enthusiasts do not realize that 711 is only specified to simulate human hearing to 10 kilohertz, and under most circumstances, that's definitely a best case scenario because depending on the type of device being tested, the 711 simulator's simulation range can shrink significantly. At last year's HBK Product Physics Conference, I gave a talk, a 20-minute overview of the 5128, the 5128 vis-a-vis 711, and more. This presentation is online at HBK's website and on their YouTube channel, so again, please do watch it if you have not already. I won't cover it all again here, but the 5128 is an exciting development because it's more human-like in every way versus 711. A more human-like eardrum, and also very significantly, a very human-like ear canal, an averaged ear canal from their 3D models of dozens of human subjects. First bend, second bend, varying cross-sections, human-like versus a 711 straight cylinder. The 5128's averaged adult human ear canal reminds me of a talk I attended at the Audio Engineering Society's first international conference on headphone technology in 2016. Andrew Bright, then of Geartech and now the Director of Audio Systems Engineering at Apple, gave an outstanding talk titled Headphones, Known Knowns and Unknown Unknowns. And perhaps I'm biased as to subject matter, but that talk was one of my favorite talks at any audio conference I've been to. He covered so much ground, and among the impossibly thorough hour of his presentation included discussion of a deeper study of wave propagation in the ear canal, how typical ear canal geometries exhibit not just significant axial modes, but also radial and circumferential modes, which he noted are problems not obviously addressed by what is essentially a single point source at the end of a tube. Anyway, at the end of this talk, Andrew Bright concluded, after systematically reviewing the results of many other studies, he concluded a couple of points among many points that really stuck out to me. Eardrum pressure is likely a good measure of hearing, and differences in a headphone's response between individuals are caused primarily by variations in ear canal length and area profile, area versus length. I remembered Andrew Bright's talk when I saw Vince Ray from HBK give a talk at the ALMA Annual Conference in 2018 when he introduced us to the 5128 for the first time, with among many other key developments covered, an exhaustively researched averaged adult human ear canal. The 5128 is now our primary headphone measurement fixture, and perhaps this is a good time in the presentation to give you a quick look at our little measurement lab at HeadPhi and how we go about measuring headphones. Our primary measurement fixture for measuring headphones and earphones is this. This is the Care Head and Torso Simulator Type 5128. The significance of the Care 5128 is that it is the only hearing simulator that simulates human hearing across the entire range, from 20 Hz to 20 kHz, simulating the full average ear canal of an adult, its canal geometries correlated with acoustic impedance measurements. So again, for the first time, the 5128 allows us to simulate an average human response over the entire frequency range through 20 kHz versus IEC 6318-4 or 711 simulators, which have an undefined high frequency region above 8 or 10 kHz. At last year's conference, I gave a presentation outlining some of the key advances with the 5128, as well as how it differs from 711. You can find that presentation online, and I hope you'll watch it if you haven't seen it already. I believe Care is also presenting key aspects of the 5128 and the research that led to it in at least a couple of talks in this conference, and certainly in far more detail than I'm qualified to present. Of course, I should also mention that in our lab here, we do also maintain different 711 measurement fixture configurations for comparisons. Because our office is located in a somewhat busy industrial park with regular noise and ground vibration, especially from truck traffic, the 5128 mannequin is inside a custom-built acoustic and vibration isolation enclosure by a company called Herzan. I believe this enclosure weighs around 1,200 pounds, so there's some good mass for its size. Within the enclosure's walls and doors are 11 layers of sound damping material with variable densities. The inside of the cabinet is lined with acoustic foam, and the mannequin sits on a pneumatic vibration control platform. Also, the cable pass-throughs are clamped and sealed with soft gaskets. So while, of course, this enclosure is not as effective as the full anechoic chambers many of you have at work, it does help a great deal to provide a consistently quiet measurement environment in our office, which again is located in an industrial park. This is the Audio Precision APX 1701 transducer test interface and the Audio Precision APX 555 audio analyzer. I spend a lot of time with the APX 555. It has the specifications and capabilities to measure any audio electronics we'd measure, but we definitely spend far more time on the APX 555 for headphone measurements. Of course, then we've added to this analyzer all of Audio Precision's electroacoustic test options. And AP seems to be increasing their focus on electroacoustic test and measurement, which is great. While the APX 555 has a comprehensively featured sequence mode, we mostly use it in its bench mode for easy viewing of several instruments at once while measuring headphones, which I'll show you shortly. Here are the two primary headphone amplifiers we use in our lab, the Benchmark HPA4 and a custom-built headphone measurement amplifier by THX. Both of these amps are based on the flagship version of THX's AAA technology, AAA standing for achromatic audio amplifier, and both are among the quietest, lowest distortion amplifiers we've ever measured. They're both quiet enough to drive even the most sensitive in-ear headphones, yet powerful enough to drive just about any headphone we'd want to test. On those occasions we need to measure an electrostatic headphone, we also have a Stax SRM 353X amplifier for electrostatic headphones. Okay, let's take a quick look at how we go about doing a headphone measurement here. Here we have a headphone on the Care 5128, and we've chosen a headphone model that we know has good symmetry for the purpose of this demonstration. Because we focus more on premium headphones at HeadFi, we've found that symmetry between the left and right channels on any given headphone, on the types of headphones we test, is more common than on less expensive mass-market headphones. And because audio enthusiasts who look at headphone measurements tend to interpret measurements very literally, which I'll talk more about later, if there is excellent left-right symmetry with a headphone, we think it's important to reflect that in the measurements. The methods we use here help us do that. Of course, it's also important to make sure your measurement setup zone channels are calibrated, and we have piston phones to help us do that here. So right now on the screen, you're seeing the scope window in the AP Analyzer's bench mode on the left. Again, I really like using bench mode as I have a clear view of several instruments at once. The headphone is on the fixture on the Care 5128, and as you'll see, I'll turn on a 20 or 30 Hz square wave. The use of low-frequency square waves for this purpose, for testing headphones, is certainly not unique to us. It's actually quite a common tool for headphone placement when measuring. However, we came up with a placement technique here that we had not previously seen that takes advantage of square wave harmonics to help us with headphone placement. Perhaps some of you already do what I'm about to show you, and if so, I would enjoy discussing it with you during the Q&A portion at the end of my presentation or offline later. Of course, I also welcome any feedback, critiques, and suggestions about what we're doing here. Okay, you can see the square wave waveform in the scope window on the left, which we can use to help get us toward left-right symmetry. Below that, you can see the level, the RMS level readout, giving one more quick indicator of whether or not we have a good seal with the headphone. You can concurrently see the frequency spectrum window on the right, and since we're having the analyzer play a square wave through the headphones, you can clearly see the abundant presence of the square wave's harmonics in the spectrum window. And that was when we noticed something interesting. The tops of the harmonics resembled a downward tilted version of the headphone's frequency response. To make use of that, to make the spectrum window more usable for us in this context for the placement and measurement of headphones, we actually decreased the FFT length. We're going to reduce it from the standard 32,000 to just 2,000. At an FFT length of just 2,000, you can see here there's simply not enough visual resolution to reveal each harmonic as you could when it was at 32,000, which for our purposes here is good, as it gives us more of a contour across the tops of the harmonics. To stabilize these contours a bit, to reduce their jumpiness, we'll turn on averaging. There you go. Now, as you can see, we have what looks rather like a downward tilting approximation of the headphone's frequency response for both channels in real time. We found this to be immensely helpful as we adjust the headphone on top of the mannequin. As far as the actual headphone placement, for circumorals or around-the-ear headphones, we start, of course, by adjusting the headband for the mannequin's head size, and then checking the position of the pinna within the cups to make sure the pinna aren't caught under the pads and that they're placed realistically within them, especially if the space inside the cups is on the smaller side. For a supraoral headphone or on-the-ear headphone, these can sometimes be challenging. We want to make sure the ear pads are resting on the ears as they do on a human, checking the mannequin's pinna very carefully for symmetrical pinna deflection. Actually, with all types of headphones, around ear, on ear, even in ear, it helps if you and another colleague or two have worn the headphones before so you know what a human-like placement range with those headphones would look or feel like. Once on the head, once we have what looks like a good seating, we'll look at the AP's Benchvue window for any possible problems. We'll typically continue then by situating one side of the headphones while we monitor all the on-screen instruments. Then we work the other side's positioning until we arrive at symmetry or near symmetry. We think it's very important to try to achieve as much symmetry from the seating as we can or as the headphone allows. Of course, sometimes you will test headphones that simply are not left-right symmetrical, but this technique helps you figure that out pretty quickly too. Once we have a good seating, and it looks like we do here, with the waveforms lining up in scope view, the RMS levels pretty much matching, and the frequency spectrum window showing good symmetry, once we have a good seating like this, we need to set the level. And this is where we now do something else a little different. I'll explain why we do this in more detail later. So instead of using a pure tone, typically you'll see 1 Pascal at 500 Hz. We used to use 90 dB SPL at 1 kHz. Instead of using pure tones, though, we now use white noise. Again, I'll explain why later. We found that going with about 80 dB SPL of white noise will typically get us to a voltage into the headphone equivalent to anywhere between 90 dB SPL and 95 dB SPL at 1 kHz. With the seating in place, we can have the AP analyzer automatically set the voltage for us to get to 80 dB SPL of white noise. With the voltage set, white noise at 80 dB SPL, we run the sweep. As you can see, we have good frequency response symmetry between both channels. With the AP analyzer, we can glean a lot of information from this one sweep. We can see total harmonic distortion, distortion product ratios, impulse response, phase, frequency response, of course, and a lot more. We'll usually run several unique seatings, always with the idea of using only realistic placements over or in the ears of the 5128, and then we average them. We also take careful notes for each sweep so that we have a record of what we did to get the results of any given seating. Being able to measure both channels at once is very helpful, and using this placement method, we've been able to do this with consistent symmetrical placement, again, as long as the headphone has tight enough channel matching to allow this. Anyway, I hope you found this demonstration portion of the presentation useful. I just wanted to give you an idea of some of the basic things we're doing and what we're using when we measure headphones here at HeadFi. Not surprisingly, the measurements from the 5128 and 711 can and often do look quite different from one another, and this will no doubt cause some confusion early on. Here are just a few examples of headphones measured on both the 5128, represented by the solid lines, compared to 711 measurements of the same headphones. While the enthusiast community will eventually get used to seeing measurements from the 5128, it may take a while, as it's facing 40 years of inertia with the 711 standard. But we're already seeing increasing adoption of the 5128, not just with big companies like Facebook and Apple, both of whom have indicated or shown use of the 5128 publicly, but also a growing number of smaller, more boutique headphone makers who are making the transition too, as well as other headphone review websites either making the transition or planning to. Still, challenges abound and will never completely go away when it comes to consumer-facing headphone measurements. And we'll face additional challenges as headphones employ new technologies. Headphones like the Audeze Mobius, the Apple AirPods Max, headphones that have advanced DSP functionality, head tracking, spatial audio. These are all very important features and functions that help define those kinds of headphones. Measuring frequency response, THD, and some of the other measurements we do here simply won't be enough to fully characterize those kinds of headphones. Anyway, I'm out of time, and you were probably hoping that I'd conclude with firm answers, but admittedly, I don't have any firm answers here except education. Educating enthusiasts on so much of what we've been talking about here is a heady challenge, and will obviously involve posting educational information, videos, and content geared toward those who, unlike many of you, and more like me, have not been formally educated on these subjects or worked in related fields. That's about all from me today for this presentation, but while I hopefully still have your attention, knowing there are physicists, engineers, researchers in this audience, I wanted to let you know I'm open to critiques, suggestions, feedback about anything we've covered here. For one specific example, earlier I mentioned the issues as we see them that can come with setting levels at just one frequency and/or normalizing after the fact at just a single frequency. I showed you how we use white noise to set levels prior to the frequency response measurement, the idea being to take into consideration more of the entire spectrum while setting levels. While not perfect, we found it makes for a comparison that in general better correlates with our subjective experience comparing the tonal balance of two or more headphones versus always lining them up at one particular frequency. I would appreciate any suggestions you may have that may better achieve this. Of course, also feel free to offer up any critiques, suggestions, or comments in the Q&A to follow, or also feel free to contact me privately. Here's my contact information. Thank you all for watching.